Hi, this is Mrs. Girija, Department of Mathematics. Today this session is for class 7, chapter exponents, and the topic below the chapter is scientific notations. Learning objectives are standard form of very big numbers, standard form of very small numbers. Let us see some real life examples where it is useful. Scientific notation is useful in some places. They are when you are calculating a very large distance, such as the diameter of a star or a diameter of a planet, and when you are checking the mass of something small like an atom. And also in scaling, when an object is too large to work with in real life, like a whole planet or a solar system. When an object is too small to work with in real life, like a water molecules. Definition of the scientific notation. Scientific notation is a standard form of writing very small or very big numbers as the product of a number and a power of 10 so that they can be easily read and compared. Let k into 10 power n is the standard form, where k is a non-zero integer or decimal. K must be greater than or equal to 1 or less than 10. Okay. N is an integer. Here there are two examples. One is for very big number and other one is for very small number. Let us see the first number. Is it possible to read the number fastly, students? It takes some more time to find the place value first. See, the number is 9 quadrillion 460 trillion meter, which is 1 light year. So, this number can be written shortly 9.46 into 10 power 15 meter, which saves the time and also space. It takes only short time to read this number and also easy to find. Let us see another example. 0.000000000025 meter. See, this is also difficult to read, which is very small number. This number also can be written 2.5 into 10 power minus 11 meter. See how fastly I read this 2.5 into 10 power minus 11 meter, but it took long time to read the number. 0.000000000025 meter, which is the radius of hydrogen atom. For this purpose only, the standard notation or scientific notation are used to write the number shortly, which is to save space and also time for us. Write the following in scientific notation. Let us see the first sum. See, the number is 590,350,000. It is an international system. Here we have to follow three rules. The first one is move the decimal point to the left or to the right such that there is only one digit in the units place. Second point is write into 10 power n after the number where n is the power of 10 given by the number of places the decimal point is moved. N is positive if the decimal point is moved to the left, and n is negative if it is moved to the right. Here the number is in whole number. In whole number, where will be the decimal? Or if you want to convert a whole number to a decimal number, what you will do? We will place the decimal point after ones place, right? Therefore, we are moving the decimal from the last number. Let us see the solution of this number. From the last means it is to the right of the given number. What is the number to the right side? It is 0. Whenever we are converting a whole number to a decimal number, it is used to place decimal to the right side of the given number. So we are moving from the right side. And also counting number of place, we are moving to the first number. Here the first point is move the decimal point to the left or to the right such that there is only one digit. One digit must be before the decimal point. The solution is we are moving from the right side. So one place we have moved, then two place we have moved, but there is lot of numbers, but we must have only one number before the decimal point. So another one step we are going to move 3, 4, 5, 6, 7, 8. 8 place we have moved from the right to left for the first point. First point is there should be one number before the decimal point. Here 5 is a number. So we are moving from right to left. On moving from right to left, the power should be positive. Okay, you know very well that you have studied the place value ones, tens, hundreds, thousand, like that. After ones place, the numbers are in the power of 10. Therefore, the number can be written like this: 5.9035 into 10 power 8. This power 8 indicate that how many steps we have moved from right side to left side. See, 8 step we have moved. And also we follow the rules that only one number is before the decimal point, 5. Okay, and the other number after the decimal point are written as it is in the given number. This is the solution: 5.9035 into 10 power 8. Okay, let us see another sum. 0.000523. Let us find a solution for this sum also. See this sum. Here the decimal place is to the left of the number. Here where is the first number? 5 is the first number. The number which is should be before the decimal place must be number 1, 2, 3 up to 9. It should not be 0 for the standard form or scientific notation. Therefore, in this number, where is the first number? 5 is the first number. Where is the decimal place? Decimal place is to the left of the first number. Now, how many steps we are going to move to reach first number? Let us see. One place we have moved just one step, but we did not reach the first number 5. Another step, Why the number are in negative? Whenever we are moving from left side to right side, the power will be in negative. As you have studied in your lower classes, the numbers after decimal is 1/10, 100th and 1000. Therefore, the power will be in negative. Likewise, next we are moving third place, fourth and fifth step only we reached the first number 5. So we have moved 5 places from the left to right. On moving from left to right, the power will be in negative. The solution for the given sum is 5.23 into 10 power minus 5. Here there should be one number before decimal point. That is the first rule we have studied. So therefore 5 was before the decimal number. Then next one, power of 10. Okay, power of 10 should be number of times we have moved. And the third point is the power of 10 should be negative or positive according to the movement of the decimal. If we moved from right to left, power should be positive, or if you moved from left to right, the power should be in negative. Here we satisfied the third rule also, the power is in negative. Okay. Express the number in standard notation. The first question is a hydrogen atom weighs. See this number? It is very difficult to read. Let us straightly go to the sum and write the number. The solution is weight of a hydrogen atom is equal to 0.00000000 0.0000000000 and 0.0000167 gram. Takes long time, right? We are going to write this number in scientific notation shortly. Okay, first of all, let us count how many steps to move from left to right to reach the first number 1. Here already I told you the 3 rules. We are moving the decimal point from left to right. On doing so, what should be the power? It should be in negative. So on moving this decimal place from left to right to reach the first number 1. Here the first number is 1 in this given number. First 1 step, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 and 24. We have moved 24 steps to reach the first number. Okay, therefore this number can be written as 1.67 into 10 to the power. What should be the power here? Minus 24 gram. The weight of the hydrogen atom is 1.67 into 10 to the power minus 24 gram. The star Sirius is about 81 quintillion kilometers from the Earth. Let us find the solution. What do you have to find here? You have to just convert the number to standard form. That's all. Solution. Distance of Sirius from Earth is equal to this number. Given number is 81 quintillion. So, how many steps you have to move? There should be one number before the decimal place. So, 8 is the first number. We have to move from right side of the given number to reach 1. There is 13 steps. See, count number of 0 is 12 and we have to place the decimal place before 1. So, totally 13 steps we are moving. Therefore, the number can be written as 8.1 into 10 to the power 13 kilometer. Power is positive because we move the decimal from the right to left. Another sum. The diameter of an atom is 0.000000015 centimeter. Here the given number is decimal number. So we have to move the decimal to the right side. Whenever we are moving the decimal place from left to right, the power will be in negative. So the solution for this sum is the diameter of an atom is equal to the given number 0.000000015 centimeter. As per rule, there should be one number before the decimal for the scientific notation. So we have to move the decimal after 1. There are number of 0 is 7 and number 1, totally 8 steps we have to move. On doing so, the answer is 1.5 into 10 to the power minus 8 centimeter because we moved the decimal place from the left to right. On moving left to right, the power will be in negative. Write the following numbers in standard form and then arrange them in ascending order. They have given these numbers for us. First, we have to convert the given number to the standard form. Then, we have to arrange in ascending order. The first number 935 into 10 to the power 4. According to the scientific notation, there should be one number before the decimal place. But here 935. Therefore, we have to move the decimal place from right side to left side before 9. On doing so, we have to add into 10 square to the given number and also place decimal point before 3. Okay, we got 9.35 into 10 to the power 4 into 10 square. Right? For the next one, 9.41 into 10 to the power 5 into 10 power 1. Because here we have moved only one step. For the next 2.5 into 10 power 7 into 10 square. Here we have moved 2 place. Here 3.5 into 10 to the power 11. 10 to the power 11 is already in the sum. Then we have moved from left to right. Therefore, the power is minus 4 as we have moved 4 steps. For the next number, 8.9 into 10 to the power 6 into 10 to the power minus 1. For the last number, 8.7 into 10 to the power 11 into 10 to the power minus 6. As you have studied in your early classes, the laws of exponent, you know very well that the base are same, we have to add the powers. Here base are 10 for every sum. Therefore, we have to add the powers. We get 9.5 into 10 to the power 6 for the first sum. 4 plus 2, 6. For the next one also 9.41 into 10 to the power 6 as 5 plus 1 is 6. The powers 5 plus 1 is 6. For the next sum 2.5 into 10 to the power 9. 7 plus 2, 9. We have to add the powers. For this 3.5 into 10 to the power 11 minus 4, we get 7. because one number is a negative. You know very well integer rules. Okay, for the next sum, 8.9 into 10 to the power 5, as we are subtracting 1 from 6. Okay, for next, 8.7 into 10 to the power 5. Now we have to arrange these numbers in ascending order. See here, you have to know, you have to keep it in mind that the powers first. Here the powers are 5 for 2 numbers and 6 for 2 numbers, 7 for 1 number and 9 for 1 number. So according to the power, you can write the numbers in ascending order, which means if the from the smallest power to largest power. If the smallest power numbers, if the powers are same, then you have to compare the decimal number here. Here, which is the smallest power? 5 is the smallest power. But there are two numbers, 8.7 into 10 to the power 5 one number, 8.9 into 10 to the power 5 another number. Here now you can compare these two numbers, 8.7 and 8.9. As we have to arrange in ascending order, the smallest number is 8.7. Therefore, 8.7 into 10 to the power 5 is the first number. Next, 8.9 into 10 to the power 5. What is the next greatest power to the first one? 6. There are also two numbers with the power 6. 9.35 into 10 to the power 6, 9.41 into 10 to the power 6. As 9.35 into 10 to the power 6 is smallest, we are writing 9.5 into 10 to the power 6 third and 9.41 into 10 to the power 6 as fourth number. Now, fifth one is 3.5 into 10 to the power 7. According to the power, I wrote this on the next. And finally, 2.5 into 10 to the power 9. Okay. You understood? Thank you.